Lesson 4.8, Scientific Notation. A number is written in scientific notation if it has the form c times 10 to the nth power. C has to be greater than 1 but less than 10. Again, it has to be between 1 and 10, but it also has to be less than 10. So it has to be like 9.999, so on. It cannot be 10, it has to be less than 10. N is an integer, positive or negative. We have three different types of numbers: standard form, product form, and scientific notation. Standard form is how you normally would write numbers, like 289,000. Product form would be taking that and making it into a decimal. Again, see this number right here, 2.89. That is between 1 and 10. Multiplying it by the place value, 100,000s. Scientific notation takes that 2.89 and multiplies it by 10 to the 5th power. You can see my invisible decimal point starts at the end of the number and goes 1, 2, 3, 4, 5 places to the left. So that's why we put the exponent 5. It's not necessarily because of the zeros, because you can see there's 3 zeros here, but 5 exponent. In the next example, 8 times 1,000 is going to be a small number, 0.008, which is 8,000. To write that as scientific notation, we put down the 8, that's between 1 and 10, multiply it by 10 to the negative 3rd power. We are moving the decimal point to the right this time. Here we were moving it to the left, this time we're moving it to the right. Because it's a really small number, we have to move it to the right, because it's less than 1 right now, to make it more than 1. And that means that this is going to be a negative exponent. Just remember that if it's a small number, smaller than 1, then it's going to be a negative exponent. If it's a big number, then it's going to be a positive exponent. Example 1. A flash of lightning consists of 3 or 4 strokes. The time between each stroke is about 0.00005 seconds. Let's see what that number actually says. This is tenths, hundredths, thousands, 10,000s, hundreds thousands. So 500,000ths of a second. Write this number in scientific notation. The reason why we use scientific notation is because it's an easier way to write really big numbers or really small numbers. You can see the decimal point clearly. First of all, see how it's such a small number? That means this exponent is going to be negative. We are going to move it to the right. 1, 2, 3, 4, 5. I actually just like to skip the product form. I think it's just one extra step. I write down the 5 times 10 to the negative 5th power. Again, if you want to write the product form, you basically, this is the place value, and that's 100,000s. We moved 5 places to the right, so the exponent's negative 5. And remember, it has to be in the form c times 10 to the nth power, and it is. You're probably wondering, why do we use the x? Well, scientific notation uses the x for multiplication because that's what the form says to write it as, c times 10 to the nth power. Again, it's probably the only time you're going to see the x again for multiplication. Example 2. A lot of times we use scientific notation for things like the weather with lightning or space. A lot of science stuff, scientific notation, which is also why you learned about it in science class. The maximum distance from Earth to Jupiter is, well, let's see, this is thousands, this is millions, so 968,100,000 kilometers. What is the distance written in scientific notation? Okay, Remember, this is a really big number. It's a really big number, then my exponent is going to be a positive. There is an invisible decimal point at the very end of the problem. I want to move it. You actually always move it to the right of the first non-zero number. So if I'm looking at it from left to right, the first non-zero number is 9, so I move it to the right of that. And again, you can see that that 9.68 is less than 10. And that's 1, 2, 3, 4, 5, 6, 7, 8 spaces. Again, I like to skip this. If you like to do it, you may, but I don't need you to go through product form. And that's 10 to the 8th power. You can see that we got rid of all the zeros at the end because we don't need them. Okay, once we put the decimal point between the 9 and the 6, we don't need those extra zeros at the end. So we moved to 8 places, and it's positive 8. The correct answer then, if you go back to the multiple choice, is C. This time we're going to try writing it from scientific notation to standard form. First thing I like to do is I actually like to just write down my number. I'm actually just going to put it up here. So 3.1. The exponent tells me how to move this decimal point. It's a positive number, positive exponent, so that means this is going to be a big number. So which way would it make it bigger, left or right? You should have said right. Right would make it a bigger number than 3.1. So I'm going to move my decimal point 7 spaces. 1, 2, 3, 4, 5, 6, 7. These empty spaces, I'm going to put zeros. Again, if you want to go through product form, you could. But I like to skip right over it. You can see this is exactly what I have. See how there's 6 zeros and then the 31? This is 31 million. For number B, you can see we have a negative exponent, and a negative exponent means that this number is going to be small. So again, I like to just write down 9.08. I'm getting to a smaller number, so I'm going to go left. Okay, that means I'm going to go left. So negative 4, which means 1, 2, 3, 4. Put a dot. Put 3 zeros in. You should even put a 0 in right before the decimal point. And again, this just tells you, I mean, the product form is really just the number multiplied by the place value. If you want to go through that way, you can. Ask me if you want to learn more about product form. So the exponent is negative, so you move 4 places to the left. Okay, pause the video and try writing these numbers in scientific notation 1 through 3. Let's just start with 1 through 3, and then we'll get to 4, 5, and 6. If you want to go through product form, you may, but you can skip right over to scientific notation. Remember, it's C, which is a number between 1 but less than 10, times 10 to the nth power. Number 1, you can see there's the 9, so to the right of the 9, I put the decimal point, which then you actually don't need the decimal point, but you can put it if you want, times 10. And then how many spaces did you move to get from the end to the right of the 9? 1, 2, 3 spaces. Number 2, to the right of the first non-zero number is between the 2 and the 5. We got 3. You don't need the zeros anymore. Times 10. Remember the decimal point started at the end. How many did you move? 1, 2, 3, 4, 5. Oops. Number 3, put the decimal point between the 1 and the 2. 1.2 is greater than 1. You do need this 0 because there's another non-zero number after it, but you don't need the end zeros. Times 10. Remember the decimal point starts at the end, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 9 places. Remember, it has nothing to do with the zeros. Okay, this time we're going into standard form. Remember, if it's a positive exponent, that means it's going to be a big number, and you're going to move right. If it's a negative exponent, that means you're going to go small, and that means you move left. So, positive exponent, let's write down the 8.2, and it's positive, so I move right to make it a bigger number, 2 spaces. 820. Number 5, write down the number, 5.51. 10 decimal places, it's a positive, so I move right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put those zeros. Make sure you have just enough zeros. Might want to rewrite it. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have, this is thousands, millions, billions, 55 billion, 100 million. Number 6, let's write down the number. It's positive 12, so I go 12 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should have left some room. So I have, let's see, thousands, millions, billion, trillion, 6,490 billion as my answer. Multiplying numbers in scientific notation. Basically what you need to do is you need to put the decimal points together, and then you need to put the powers of 10 together. So all of this is just saying to do that, which they did right here in this problem. The commutative and associative property tell us we can switch them around because this is all multiplication. You can see by the x's. So multiply 6.5 times 8.4. You get 54.6. Now remember the rules of exponents. This has the same base of 10, so we add the exponents together. So 10 to the 14th power. You can see this is not in scientific notation. Why? Look at this number. 54 is not between 1 and 10. That means I need to move this decimal point over so it's 5.46. Because I do that, because I moved it over one spot, I'm going to add another power of 10, which means I add the power of 10 to the 14. So I'm going to get 5.46 times 10 to the 15th power. This is now scientific notation. Be careful that you don't just stop here. You have to make sure it's in scientific notation, that the number is between 1 but less than 10. Go ahead and try these two problems. Remember to move the decimals next to each other and move the powers next to each other. Pause the video at this time. For number 7, 6.75 times 9.2 becomes 62.1. 10 thirds plus 10 to the 8th, 8 plus 3 is 11. Is the scientific notation? Well, look at the 62.1. Move the decimal point. That means I'm going to add 1 to this exponent. So you have 6.21 times 10 to the 12th. Same thing with 8. 2.35 times 4. $9.4. Multiply by the powers 10, 6, 10 to the 6th, 10 to the 9th power, which is going to be 15. This is already scientific notation. You're done.